on the basis of electricity can be classified into three groups, that is conductor, semiconductor and insulator. Now conductor, for example metal, which allow to flow of electron. That means the resistivity of conductor is very low. For that we know that 1 upon resistivity is conductivity. So conductivity is very high in case of conductor. Now opposite to conductor there is insulator. For example we can say wood or plastic, which does not allow to flow of electrons. In that the resistivity of insulator is very high, and due to that the conductivity is low. Now we have to focus on semiconductor. There are two examples of semiconductor which are commonly used, silicon and germanium. The resistivity and conductivity of semiconductor lies between conductor and insulator, that is called as a semiconductor. Now there are two types of semiconductor. One is intrinsic and another is extrinsic semiconductor. The pure form of semiconductor is called as intrinsic semiconductor, and in which there is less free electron for conduction. And in extrinsic semiconductor, if we add the impurity or we can say doping in the semiconductor, it is called as a extrinsic semiconductor. The electrical conductivity of intrinsic semiconductor is a function of temperature alone, whereas the electrical conductivity of extrinsic semiconductor depends upon the temperature as well as on the impurity atom doped in the structure. Okay. Now there are again two types of extrinsic semiconductor. One is P type of semiconductor and another is N type of semiconductor. P type of semiconductor, if we add a small impurity of trivalent atom in silicon structure, for example boron or aluminium or gallium, if we add such an impurity in a silicon or germanium crystal, it will create a P type of semiconductor. And N type of semiconductor, if we add pentavalent impurity, for example pentavalent phosphorus or arsenic, if we add such a pentavalent impurity in silicon or germanium crystal, then it will create a N type of semiconductor. Now this P type and N type, when we join these two blocks or two semiconductor, then it will create a p-n junction diode. Now again p-n junction diode. Now see, if we take a P type semiconductor block and N type of semiconductor block, we know that the P type semiconductor contains majority charge carriers are holes and minority charge carriers are free electrons. You can say electrons. And in N type of semiconductor, majority charge carriers in N type of semiconductor are free electrons. minority charge carriers are holes. We can denote these are free electrons, and these are the holes. Now if we join these two blocks,